Thank you very much for your time for watching this video. In this tutorial, we will discuss how the servers interact with each other and how a request gets completed on Ramanujan. And also in this tutorial, we will go through the code as well. So, Ramanujan is created to follow an async flow wherein the dev console where the developer can submit their code. That request goes to middleware and middleware tries to check the code. It creates it converts that code into an intermediate code, and once it checks that hey, all is good, it creates an async ID and it sends back to dev console. And behind the scene, a middleware will call other servers, and those orchestrator servers will actually orchestrate that code processing through some device. But now dev console has the async ID. It will be polling middleware at some time interval with that async ID. And what middleware can do is that it will check that, hey, is that async ID already done, or it's not done, or is it in progress? And it will return back the status to the dev console. So now coming to the main flow where middleware request orchestrator. Now here, after converting it to the required excuse me, sorry, it converting into an intermediate code. It um, it so the middleware has the DAG with itself, right? So if I would say about let's say developer has written code in such flow, right, where the DAG creates like this, then middleware knows that hey, what is the DAG and what is the head of the DAG. And also each node in the graph has a pointer or has an unique identifier to their children. And similarly, each children, each child has an identifier to its parent. So for example, N0 understands that its next child are T1 and T2, and similarly T2 and T1 knows that N0 is their parent. And similarly, T1 and T2 have a child called N1, and N1 understand that its parent is T2 and T1. Now, how middleware will orchestrate this processing is that whenever a particular processing node is completed, let's say T2 is done, right, but T1 is in progress. So when it understands that hey, T2 is done, right, it will check are all. So first of all, it will check what are the children. Then it will say that hey, this is N1. Then it from N1 it will understand what are the parents. They are T2 and T1. Now it can understand that is are both T2 and T1 done. And if they are done, then only it will submit a request to orchestrator for processing N1. Otherwise, it will wait, right? Um, yeah. So coming back to the diagram, so what it does is like until all the tag elements are not completed, it will submit that tag element to the orchestrator. Now again, orchestrator will follow the same async design that middleware is following for working up with dev console. So what orchestrator will do is it will register the request and it will return back an orchestrator async ID. And now, after getting this orchestrator async ID, middleware will make a call to Kafka manager. Now, Kafka manager is it's a service and it's written in such a way that it can be used on any kind of pub sub um, service. It can work with Kafka or it can work with Google Cloud pub sub, or if you want to have a local kind of a pub sub thing which is very simple and just for dev work, that can also be done. But it can having said that, it can work with GCP and Kafka. You can very much extend this service to adapt to any kind of pub sub. Let's say we want to go with AWS, we can do that for sure. So once middleware has the orchestrator async ID, it will send the orchestrator async ID to Kafka manager. Now, Kafka manager will publish that onto the pub sub queue, and uh, whenever the consumer of this Kafka manager will get back the message on the queue, it will make a call to middleware that, hey, check orchestrator async ID. Now, after getting this check API, middleware will check with orchestrator. Now, orchestrator will tell that what is the status. And in case the status is success or it's failure, it will return back to Kafka manager. Or is it in progress? It will return back to Kafka manager. And if it's in progress, then Kafka manager will again publish it to the queue. And after some time, it will consume that message back, and hence we will follow the loop. But when the status is success, then uh, the middleware will understand what are the children for that particular node that has just got processed, and after that it will make decision on if it wants to process the next child, as we just discussed before. For the DAG I just showed here, that let's say it got success for T2. Now it will check, okay, child is N1, but are all parents done? Are T1 and T2 done? If T1 has already been processed, it will go ahead and submit a request for N1. Otherwise, it will, whenever the processing for T1 will be done, that will make the request to N1, make the request to orchestrator to process N1. So that's the flow, and that's flow at very high level. Now, if we would want to see how the code works, all the servers right now are using Vertex for creating its server process. But moving forward, we might do away with Vertex, and we might have simple things here to create server. Um, Having said that, right now, how it works is that all the server processes have the main file called as main vertical, and that main vertical will initiate all the Spring related configurations. It will create all the singletons. However, moving forward, I have a plan to move away from Spring as well. The code will be really simple. But right now we are having Spring, and we are having servers through Vertex. Then what happens is that we will go to the HTTP vertical. Now there is this class HTTP vertical which actually hosts the server process, and so it creates a server, and there is a port on which it's going to listen, and there are some APIs on which that server will listen, and it will understand how to forward the API request to proper class. Um, the one for our interest are run, status, right? What this run API does is it makes the request from, so dev console will call this API to middleware, which will submit the code to middleware. Now we'll see this, how translate and run handler works. So it will get the code from the payload. Uh, it will check if there is any compilation error, and then it will call this run code. Now what this translate service.translate does is it creates the tag. So if I see translate response, it creates a tag. So, and that tag is also, so tag is not just a node having that string code, but it also has the um, intermediate code. So that intermediate code is set in this field as rule engine input. So if you would see this class, there are a bunch of nodes for that intermediate code. So let's say if we want to have variable, we want to have command, we want to have if, etc. You can go through all these classes, how these classes work. There is no intelligence as such in this. So for example, if I would see if, then it just says that, hey, what is the condition ID, what is if command ID, and what is else command ID. So all so it just have the IDs to the blocks, right? Now what happens is, let's say if this is if class, right, and it's having this condition ID. So what this would mean is that there is an object in condition list uh, uh, which is going to have that particular ID. So rule engine input unit has this ID. Uh, so yeah, so we got the tag with us, and now what it's going to do is it will start firing the calls for the head of the tag. Okay. No, yeah. So before doing that, as we discussed in the diagram, right? Once we have the tag, we have converted that to the intermediate code. I'm going to return back the async ID. So that's what is happening here. So in my data store, I'm going to add that, hey, this is a new async ID. And once that is done, I'm just going to return back this async ID. And what these callbacks will do is it will go back and respond back on the network layer. Once we have responded back to the dev console, we are going to initialize DB entries. Now, what I mean here by init DB entries is that we would want to persist, we would want to maintain the states of variables and arrays, right? That is going to happen here. So even if your node changes, right? But your nodes are sharing some common variables, so that have to be maintained somewhere. So that's what happens, that in this initdb entries, we'll create an entry for the variables and arrays that are shared across stack. Then once that is done, I'm going to uh, call this run dag element id, and uh, then it will just make, so these are what, so this is a common method which will keep happening before I want to run any tag element ID. So so let's say Kafka manager consumed some message and it calls to middleware. Now if I'm having a lot of servers of middleware behind a load balancer, the request of that check async ID might not fall on the server which actually initiated the whole process, right? So so I would not have the tag element with me. Now it's not in the memory, right? It's not the same process. Hence, I'm not having that in my memory. And also, I'm not sure what that direct element is, what are the variables for that. So that's what happens. So whenever this method is getting called, I'm going to get the tag element for that. And also I'm going to refresh my variables and arrays, the ones that I just shared about, right? The global variables and global arrays, which are used among different DAG nodes. So once that refreshing is happened, I'm going to make a call to orchestrator. And so in this, yeah, so once that is done, so there is this retry mechanism. I go here. Yeah, so it, no, no, yeah, okay, my bad. Yeah, so we made a call, and once orchestrator has taken that request and it returns back the async ID, I'm going to get that async ID in this get async task ID handler, and I'm going to store that ID with me. So for a given async ID, So this async ID is something which is mapped with the dev console request, and that async ID can have a lot of orchestrator IDs, right? If I'm having 10 DAG elements, then I'm going to have 10 orchestrator ID. So I'm just going to maintain a mapping that for what DAG element ID, what is the orchestrator ID with me. And once I'm done with that, yeah, once I'm done with that, I'm going to make a call to my Kafka manager. And if we'll see the code of Kafka manager, it can either publish it if you are on some PubSub service, if you have registered the Kafka manager on some PubSub service. There are ways by which you can do for Kafka, you can do for PubSub. You can see here. So in this we have Kafka implementations, we have PubSub implementations, and yeah. So for your local testing, we can rely on low load. What it does is that it will maintain a in-memory queue of events, and it will just try to simulate your publisher consumer model. So that's the best way to do uh, uh, dev work if you do not want to run on any infrastructure. Um, yeah. So once that is done, now now this is done, right? Now, as we saw that our Kafka manager will make some calls to middleware to check, and that is done via status calls. I think it calls Kafka manager calls this API process next. So it checks the status of the ongoing orchestrator ID, and if that is successful, it will make the call to the next one. So here we come. Process next tag element service. Then we'll make this. Then yeah, it will get the mapping. Now again, it's fully distributed, right? So whatever request come back to middleware from Kafka manager might not be the same server which actually initiated it, right? So we have to maintain the mapping. So yeah, that's what we are getting here. We are getting the mapping from orchestrator async service. We are getting from the data store, my bad. So we right now follow, we have MySQL implementation as well as in-memory database as well, which is configurable. Um, yeah, so we got what orchestrator ID is, and we'll make the status call to the orchestrator service, and if it's successful, um, yeah, if it's in progress, I'm going to call again to the Kafka manager to publish it into its queue. Otherwise, if it's successful, then what I'm going to do is that I'll get what I'll get what variables and what arrays that particular DAG element used, which are global. I'll refresh those variables, and once that is done, I'm going to get the next ID. Now this dot get next ID has that heuristic to check. Yeah, I mean, it just gets the next ID. It doesn't do anything. What's the main method is this call next elements. Now this has that information on. So this calls this call next element if it's not dependent. This is what it checks, that it will check the parent and uh, children, and if all parents are done, then only it will call that next stack element. So yeah, that that is how middleware service works. You can go through the code. So one thing which can be important for you to check is this class translate. So we are obviously getting the DAG elements. Now creation of that DAG graph is one part, but how uh, the code is converted to intermediate code, we can check into this. That code snippet, populate all. Yeah, so this code converter dot interpret will convert your whole Ramanujan code into an intermediate code, which will be used by the rule engine or the interpreter to run on the devices. So you can go through the code. So, um, so right now the lexer and the parser um, all is handwritten right now, and once we understand what kind of node on the abstract syntax tree we are on, we create that kind of an entry. So you can go through the code. Um, Also, as a future work item, what I'm doing is that I'm going to use ANTLR, and in future, I want Ramanujan platform to be working with Python. So it will be working with both the Ramanujan language and also Python. So as a future work item, I'm going to have ANTLR as my lexer and the parser, and it will give me the relevant AST, and then my logic will kick in to convert that AST into my intermediate code. Yeah, and so coming to orchestrator um, service. Yeah, again we have this main vertical, and in this I'm going to have my HTTP class, HTTP vertical class, which creates the server, and it exposes um, certain APIs. Now there are a lot of things. Uh, so yeah, so um, this pings open is called by the device. Pings open and pings heartbeat is called by device. So what pings open means is that device says that hey, I request for I request for some processing, and after getting this API request, orchestrator will register the device and its server stats, its device stats, and right now the selection of device is very simple. It's just DQ, but in future will be, because we are getting the device stats which will be having CPU stats and other important stats. We'll select the appropriate device for a given processing. Then we have this ping slash heartbeat API. What it means is that once device has accepted processing to do, now the device is busy, right? But how our orchestrator will know that device is still working or not working, or it has got killed, or something bad has happened, or anything. I mean, anything can happen, right? Or what means that the device is no more processing. Then for that, what happens is that at regular interval, my device will send heartbeat that hey, I'm alive, I'm processing, and in case the orchestrator doesn't get heartbeat for some amount of time, it will mark the device as dead, and if there is some processing which was happening on that, it will push it will push that processing to some other device. Then this status API is the same that middleware will call to the orchestrator to check that, hey, is this orchestrator racing ID done or it's not done, right? And this orchestrate API is for middleware to tell orchestrator that, hey, I want this processing done. Uh, then yeah, these are the important APIs. So the code of orchestrator is pretty simple. It manages the states of devices. It manages what requests are there. Uh, it dequeues the request. Send it maps a request to a device, and then a device can take its processing. It's very concisely talked about in this particular diagram. So middleware says that, hey, run this tag element ID. It registers the request. It gives back orchestrator async ID. And in parallel, device X might have said open ping. Now the orchestrator would have already mapped uh, this request to device X, and then it will just return back the DAG ID and the intermediate code. Device X will process it. It will send the processing data. Now orchestrator will push that to some data store. Now whenever middleware comes back to orchestrator again for the status check, orchestrator will just check from the data store that, hey, this is done. These are the shared variables that were used, and that processing data shall be sent back to middleware. So yeah, this is all. Maybe I'll just so so the important part comes in the Ramanujan native library, which is the interpreter. I'll create another tutorial for that because that will be some more detailed. I'll post that separately. But I would encourage you to go through the code by yourself once. That would be the greatest thing to do. Thanks a lot for your time. Really appreciate it. Thank you very much, and hope you have a great time on this project. Thank you so much.